So you can build a golden template the old school way, boot an ISO, click through an installer, tweak a few things and convert to a template, then call it a day. Everything's good and gravy. But if you ever found yourself doing that more than once and you already know the problem, your template isn't the automation in this case, it's just a starting point. And today we're doing this the cloud way. So we're gonna grab a cloud image, we're gonna turn it into a clean Cloud-Init template, then actually use how it's meant to be used for repeatable deployments with a real workflow using Terraform. Welcome back to 45 HomeLab. I'm Zack Perry, and this is part 2 of the Proxmox Cloud-Init series. In part 1, we kind of did a general overview, what Cloud-Init is, and what problem it's solving. Now we're going hands-on, we're going to be deploying a Cloud-Init image, we're going to be building a reusable template, and then taking that template, we're going to put it into an actual real workflow. High level, here's what we're doing. We are converting a cloud image, we're going to convert that into a template, then we're going to be using that template to make fast iterations of clones of that template, turning those clones into IAC or infrastructure as code deployments. When I was going through this, I was like, why cloud images and Cloud-Init instead of the traditional golden template, which I typically do? So let's kind of address that question. Now, why not just install Ubuntu once, customize it, convert it to a template, and then you're good? So that works until you try to scale it. A traditional ISO build gold template sort of image is great for a lot of things. Still the vast majority of my HomeLab, but it's good for one-off deployments of VMs you'll keep forever, highly customizable base images, tons of pre-installed packages, environments where you don't care about the drift of doing a couple of installs on one template and another, but Cloud-Init plus cloud images have what you want when you want. It has fast, repeatable, disposable VMs, consistency, so you have the same baseline every time, per VM identity, hostname, SSH key, users, network, and that infrastructure as code workflow, so Terraform, OpenTofu, CI pipeline, so you're going through a lot of destroy and rebuild, testing things out, and here's kind of the real difference between those. Now with the golden template approach, and I could not think of a better term, but you're baking personality kind of into the image. So if you want to change something later, you remake the template, you then version those templates. Hope you don't, forget which template is which again, that is the story of my HomeLab life. And drift still happens once you start logging in manually, changing things, kind of as I mentioned there. Now, the Cloud-Init approach, on the other hand, you keep the template thin and generic, and you apply personality at boot time. So one template has infinite unique machines or machine deployments, and once you pair that with something like Terraform, you get that part that makes it feel like a real platform as to why you're using this instead. Now, the template build, one time only, the goal for the base VM, this VM should be, number one, clean of course, generic, and not logged into manually. So it's just going to be something that you make and then immediately into a template. It's never going to be used directly, only cloned. Now, those high-level steps, we're going to go into it in a little more detail. We're going to create an empty VM shell, import the cloud image disk, attach it as a primary drive. Then we're going to add a Cloud-Init drive, which will have our actual password, username, blah, blah, blah. And then we're going to fix the boot order in the console, and we are going to convert that to a template. Now, creating the base VM CLI method, you can copy and paste this here, but let's take a look at what we got. All right, so now that we actually have our setup here, let's actually look first at kind of what it looks like in the GUI. I did have some issues with the GUI for some reason or another. It was kind of picky about the actual file type. I'll show that a little bit more what I mean when I get to the command line here. But typically, for somebody who does have more than 2 brain cells to rub together, what you can do is, somebody might have it in the comments here, but what you typically do is you would go in, and I believe I put this in LXC for whatever reason, and we'll go to import. No, didn't put it there because I moved it over to my SSD pool. And I didn't move it to my SSD pool. Where did I put it? My goodness. HD pool, no, local, import. Where did I clear? No, there it is. 5th or 6th times the charm, I guess. So we have our raw image here where we actually got it. But the thing with this is that while it does want a raw image, one thing that I ran into is if you do an actual QEMU info, command escaped me right now, it's in here, but QEMU-image info, on that, it will show that it is not a raw image, but it's a QCOW2, which should be fine, but I was running into some issues with it there. But typically all you would do is take this, you'd go in, create a VM itself, and as you normally would, let's just call this init. I'm so sorry to our viewers across the pond. I cannot say init without saying it in a terrible British accent. What we'll do is we do not choose any media here, and then everything else will just kind of be boilerplate as it is, but here's something that we do. So we will remove the image, no disks here, and we're going to import. So we would choose where actual image is here, so we can see image-raw. Then we would select our target storage, like if we don't want it on PV assets, we want it on SSD pool, etc. We would just go through there. Then CPU, that's not going to change from how you typically create a VM. Same thing with memory, network, and then you would just confirm it, and then you'd finish. And you're not going to start it after you create, because there's a few more things that would need to typically be done. Now, let's go to 108 here, and we can go in, see our Cloud-Init. We have none there. So what you would typically do is go to Hardware, Add, Cloud-Init. There we go. And a lot of things I've seen online, some use SATA, some use SCSI. The majority that I've seen use IDE, and they typically state this as IDE 2. And then we'll go to, being that it's an IDE, I'm not gonna, even if it is tiny, I'm not gonna waste the SSD pool on it. We'll just go HDD pool here, and then it would be a raw image. I already have that one already made actually, so we can't do that. So we'll go add. And then from there, if you go back to Cloud-Init, you can see all of your stuff here where you can create it, set your IP, either statically, add SSH keys, all that good stuff here. And then you would just go in, make sure your boot order is set properly. So our SCSI disk, we have that. And then online. Now, I'm gonna do it in the command line for our actual image. So let's actually see what that looks like. And I'm just gonna bring my actual terminal up here, and let's go. So we can see we have our cloud image here. We already have that downloaded. If we were going to actually create that VM, this is just pretty much what we did in the command line or in the GUI. And then we're going to create it, and 9,000 likely, I believe, already exists. So let's go home. Took me a second to find it there. This is not my normal keyboard. And let's do 9001. And that'll take a second. There we go. And now if we actually move this over to the side, you can see 9001 getting created there. And then we're going to import our disk. So next, and we'll change this to 9001 again. And this is just our cloud image, and we want it to live on our SSD pool. So 9001. And then it's going to transfer all that pretty quickly there. And we need to attach an imported disk. So let's copy that, boom, here. And let's go 9001. And then home 9001. And we can see that's now attached. And then we're going to attach our Cloud-Init drive. So the only reason I'm showing the contrast between these is because, one, I had issues with the GUI here, and a lot of people will do this through the command line for a Cloud-Init image, just because it is a bit quicker if you already do have one set up here where you're not kind of walking through the steps. But let's go here. So, yep, we have that, generating cloud image. And then we want to make sure our boot config is set to the proper disk, which is going to be our SCSI 0. Would have been much easier if I just deleted the 9,000 VM that I had instead of having to take away a 0, add a 1 every shot. But let's see. Cloud images. Oh, not that. So I did notice that there was something with whenever I was using anything as opposed to, VGA or using one of the typical things that you would, kind of went a little crazy with this. And I was like, all right, make sure that you drive home that VGA is what should be used, serial 0. And apparently cloud images love it. So let's go QM set here. And again, someone with more than 2 brain cells could probably be like, oh yeah, the reason VGA works and this doesn't, XYZ, but let's actually go here. And then, of course, we want to have QEMU agent. This is going to allow the Proxmox host to actually talk to the VM or the cloud image at a lower level. Now, this will just do the guest agent, but you actually have to install it or enable it after the fact. So let's go here and here. And that's good there. And then we just simply convert it. And there we go. Now, if we go back to our actual template here, we can see 9001 Cloud-Init, and we can see that it just converted to a template for us. So with that said, let's actually go in, talk about a few more things here, and then we'll actually get into the actual Terraform deployment itself. So with that done, this gives you a forever template that stays clean. So let's say I got something like the HL15 Beast here. We have, this gives us a lot of freedom to configure things. Let's say we want each VM's boot disk to use our 8-disk mirror ZFS SSD pool, and then a disk or two for everyday storage. Then our HDD pool comes into the mix with RAID Z2 VDEV of 15 drives. And this allows you to have a platform like Google's Compute Engine or AWS EC2, all on-prem, locally hosted, and completely using your own hardware. Let's look at the template versus the clone. So your template gets the base OS disk, Cloud-Init drive, it gets the hardware default, so your CPU type, SCSI controller, etc. And on the other hand, your clone is going to get the username, your SSH keys, the IP config, whether that be DHCP or static, and the host name, and a slew of other things. So there are some optional things. So the cloud config packages, scripts, bootstrap, and that's kind of the magic behind the whole thing. So we have one template, but infinite unique VMs that are spun up like that. And so the real workflow comes where you introduce things like Terraform plus Proxmox to kind of put it all together. So the whole point of doing a Cloud-Init is a workflow kind of like this. And I am by no means an expert, but you're going to build a Cloud-Init template once. You're going to put Terraform or OpenTofu in a Git repo or on a local machine that can contact the Proxmox node. You're going to deploy VMs by changing code and running apply, and optionally hand off to Ansible for further automation. Now, here's the key value. Terraform doesn't actually configure Linux. Terraform configures Proxmox. Cloud-Init configures the guest. So when you combine them, you get real provisioning. Now, here's what we kind of solved with Cloud Image, not we, not me, but the smarter people. Now, when you build VMs, the classic Proxmox way, you get a VM. When you build the VMs with Terraform plus Cloud-Init, you get a rebuildable system, and now you can do things like, let's see, we can do Terraform destroy, Terraform apply. Now, what exactly those do, you can probably take a guess and get it right, but we're going to take a look at that. But basically what they'll do is get you back to a clean state where you can do things like lab testing, upgrade rehearsals. Something is acting weird, so let's just redeploy it. It gives you repeatable infrastructure, and this is the exact point where Proxmox starts feeling like a real cloud platform, if that's the use case that you want to have for it. You have real Cloud-Init snippets, packages, commands, things like that. So the Proxmox's built-in Cloud-Init fields are great for users, SSH keys, DHCP, static IP, but when you want real boot logic, like let's say installing QEMU guest agent, which Proxmox handles, but other things like adding a message of the day that prints the IP at login, writing config files, running startup scripts, and there are so many other things that's just scratching the surface. But that's where Cloud-Init user data YAML shines. So in Terraform, we upload a cloud config snippet and then reference it as a user underscore data underscore file underscore ID. And that's where it gets you from VM exists to VM exists, and it's ready to use with everything you need. So use cases that actually matter in a home lab. A lot of things with Terraform and Cloud-Init are on the enterprise side, but this workflow is perfect for a lot of great things like Kubernetes nodes. You can spin up 3 to 10 nodes, destroy them, repeat, CI runner, so things like ephemeral VMs, testing Proxmox upgrades or any upgrades to your infrastructure before you actually implement it into your production. Service sandboxes, so deploy, break, redeploy, and multi-VM labs. And now let's actually go in and look at a little bit of the Terraform portion, kind of where it all gets tied together. All right, so now we have our Proxmox actually set up. We have our Terraform set up on my home client, on my workstation. Let's actually go here, and we can see we have our Proxmox. We only have up to VM 108. And you can see that we have our Proxmox IAC directory over here. To actually have it talk to Proxmox correctly, Terraform I mean, you would go into data center and you would just set up an API token for them to speak to one another. It's kind of, the whole Terraform part of this is a bit out of scope of this video, or it would go for a whole while longer, and I do not want to subject you people to that torture in one video. If you do want to see it in a separate one, let me know in the comments, but let's go in and actually take a look at a few things. So again, Terraform, bit out of the scope of this, so because I pretty much just learned it myself in the last week, and I am by no means an expert at all. So we have here just a few different things within our Cloud-Init file, and the big one that we're going to do is let's take a look at our main.tf to kind of see what it's doing here. So there is quite a few things that it's doing. Now, I was running into issues like it would deploy the VM, or the 3 VMs in this case, and it would do DHCP, and I had just recently redone my whole HomeLab and everything, all of my work clients, so I didn't have anything to like scan for IPs, anything like that, and was too lazy to do it. So I was like, let's do a little chat GPT, and how can I put this in Terraform so it'll output the IP for me? And lo and behold, put it here, but it's going to pretty much do a message of the day, give us that IP. It's going to tell us what that IP is once it finishes running the Terraform config. It is telling us what disk IDs to use. We're using SCSI0. We're using VirtIO for our network device, our data store ID. So this is going to be using our SSD pool because we defined that in another one of these files here. But the thing that I kind of want to highlight here, without me butchering how Terraform actually works, is let's just do Terraform apply that I mentioned earlier. And when I run this, after I enter yes, I want you to keep an eye on the Proxmox side of the screen there where that 108 init is. So let's do this, and we can see it is creating, and it is already creating 9, 10, and 11, so labs 01, 02, and 03. And you can see it's setting those up pretty quickly there. Now, you're just thinking, okay, what's the difference with this? I could just spin up a couple of VMs. I could script it out just to be like boom, boom, boom with my VM templates that I use an ISO image on, etc. So the good thing about these is that they are very small in scope compared to a lot of VM templates using an ISO. But let's actually look here, and it looks like it's going, but is it actually? I could be lying to you right now. So let's go, and we can actually see it working. You know, there's still a little bit going on in the background here. And this is deploying 3 Ubuntu 22 VMs. And once that finishes here, boom, we can actually see here. Let's see if SSH works. So root at 192.168.2.231, boom, yes. And let's see. Permission denied, public key access. Okay, that makes sense. So we'll go in here, let's log in here, and obviously I had something a little messed up with it, but let's go here and password. No, I changed my SSH keys. That's why my public key is different from what I did before. So this would work, but it's not going to at the moment because those keys are different, but you can see it is contacting it. Those VMs are up and everything. It just have your login credentials, whether that be SSH keys or root itself, set up correctly. So, and I'm pretty sure that'll be the case of all of them here. But one other thing we can actually check is I may not have set this up as root now that I think about it. Let's see. That was it. All right, I'm an idiot. Nope, still works. Didn't make the changes. So yeah, that was just me sweating on camera for a few seconds there, being like, I thought I tested that. Anyways, so let's go through that. We see we have our 3 here, but let's say, oh no, we forgot to install some very important packages and some tools onto our VMs that we need for testing. So there's a very important tool that I deploy on every VM, every machine. This isn't true because I do a lot of work in enterprise and I don't deploy this on customer systems. So let's go through and actually see what we have here. So if we want to add a VM itself, or not a VM, if we want to add a package, we're going to go to first we're going to exit. And let's see, we want to go into our vim cloud-init.yaml.tftpl. TFTPL. So that's our Terraform template. I believe that's what it is. And let's go in Cloud-Init. So you can see we have packages that it's installing. Another thing that this is doing is it's also enabling QEMU, or QEMU guest run inside of the VM itself, so you don't have to do that manually. But this is the very important package that we need to install. It's called SL. Some of you know why I'm smiling right now. So we're going to do that, and if we want to have that running, let's say we have more than 3, let's say we're lazy like I am, and we don't want to actually go and install it on all of them. So let's just do a Terraform destroy. So we can see here, it's just getting us to confirm it, and then it's going to destroy those very, very quickly. And my favorite part about this is that our guy behind the camera, Joe, he's going to have to edit this, and he's going to be wondering, why is he calling me out right now? Why is he smiling, talking about installing a package? Well, he's going to see. A lot of you are already going to be aware, but let's do Terraform apply now. Hey, Joe, how you doing? So now we're going to go yes. All right, so we now have that deployed. We have our actual IPs. So now that we actually know what our login credentials are and everything, let's go in and see what that command does. So let's just take one more look here. Let's see, or actually, cloud. So that is going to be our SL command, and we are now going to SSH into, let's say, 228. Yes, there we go. So now let's do SL. We'll full screen this because it's a very important command. And
don't do it to me. I beg you. No.
Very important command.
You have nothing to do with this decision.
So
what is your job exactly besides making balloon animals?
You can install quick things like that, very important things that every Linux system needs, like the SL command. So that is using Cloud-Init Terraform at a very high, silly level. So yeah, with that, let's go back into the future Zack, where he's going to close things out, and then he's just going to wait patiently while Joe edits this and discovers what is on the screen.
No.
So yeah, you can install an OS once, clone it forever. Again, it's probably what I'm going to do for the foreseeable future, just because it's what I'm used to. But if you want Proxmox to feel like a cloud platform, this is the path. So as I mentioned, cloud image, the Cloud-Init template, then use Terraform or OpenTofu for your deployments. And do you want to see a fully set up Terraform in a future video? Let me know in the comments down below, or any other ideas you might have. And if you want to see everything we have on offer, head on over to the store.45homelab.com, where you can pick up a system to meet any of your needs. Our socials are going to be in the description down below. I'm Zack. See y'all in the next one.